Now, last time we had a look at exothermic and endothermic reactions. Exo being an exiting energy to my reaction, endothermic being entering of energy, so energy entering the reaction. That was characterized by the fact that in my exothermic, the reactants were higher than my products. I had a negative change in energy. And endothermic, the reactants were lower than my products. So there was a positive change in energy. Now, for higher tier, we have to work out how this happens and how we can use this information in the reaction profile to tell us what happens. Now, in all reactions, there is a breaking of all the bonds. So all bonds break, and then new bonds are made. Now, for instance, we're going to do combustion. So in methane, I have CH4. We obviously did that in bonding. Carbon has the 4. That methane combines with oxygen, 2 atoms of oxygen, to make 2 molecules of water and 1 molecule of CO2. Now in this situation, what's actually happened is these bonds, those 4 bonds, and these 2 bonds have broken, and then these 2 bonds have been made. Oh, these 6 bonds have been made. So bonds get broken at the beginning of a reaction and they get made at the end. Now, breaking bonds requires energy. For us to pull apart those atoms, it takes in energy. Anything that takes in energy is endothermic. Anything that makes energy, think about it, when these 2 are attracted to each other, they produce that energy, kinetic energy, that makes them exothermic. So we can actually think, so this is often characterized by bendo, mexo. Breaking bonds is endothermic, making bonds is exothermic. Now we can always describe a exothermic reaction as one where the energy to break bonds is less than the energy made when bonds are made. For endothermic, the energy to break bonds is more than the energy made in bond making. Now there are a number of calculations, but I'm going to save that for another video.